which is taken from NCERT, and that will be very important as far as your CET, JEE and NEET is concerned. Now in the state board syllabus or in your 11th and 12th standard textbook, gravitation lesson is covered only in 11th. It is not mentioned in the 12th. But as far as MST CET syllabus is concerned of 2022, they have enlisted gravitation for 11th as well as 12th. So from where it is? It is from NCERT or CBSE. So today we need to start with the model number 1, that is for gravitation. Now, whenever we are talking about gravitation, there must be a first law in our mind, that is Newton's law of gravitation. So if suppose we have a object A with mass m1, object B with the mass m2, and they both are separated with the distance of r, many of the time what students are making mistakes, that is most important to understand. While drawing this diagram, we have found, because we have checked few board papers, so in that what we can understand, if students are drawing A and B, they are writing like this. So it is not correct. The distance must be from the center of object. Must be from center of object. So how it would be? Right? Here is object A, object B, M1, M2, and the distance is R. This is the correct diagram, right? Now, if you will ask, sir, why then this representation is like this? Because in the presentations or PPT, we have some restrictions, so that's why we have picture like this. But actually, in the examination, this diagram is needed. So, if object A and object B are separated with the distance R, then what the law says, the force of attraction between the two objects is towards each other. Force of attraction between the two objects towards each other. It means first statement must be, what must be your first statement? The force of attraction between them is directly proportional product of their masses. So that must be directly proportional to the product of their masses. Let us consider the mass of first object is 10 grams and mass of second object is 20 grams. Right?
Yes.
Now, if we will consider that 10 into 20 is 200 grams, it doesn't mean their force is 200 Newton.
Yes.
Why? Because it is just proportionality. It is just proportionality. When it comes to equality, then we can consider that yes, it must be 200 newtons. But it is not like that. So just for proportionality, first statement is force of attraction between them is directly proportional to the product of their masses. Now what is the second statement, that we'll see. You might have revised this in 9th standard or 10th standard, right? So we have to recall from that. The second statement, the force of attraction is inversely proportional proportional to the square of distance between two masses, right? So what is our second statement? Force of attraction is inversely proportional to the square of
distance between two masses.
distance between two masses. So इन दोनों के बीच में whatever may be the distance, that must be inversely proportional. Let us consider two magnets are there. Let us consider two magnets are there of two different pole, north and south. If two bar magnets are there and if I am holding like this, north, south, and on this side, south, north. So if I keep it at very farthest distance, they may not attract,
Yes.
right? But as soon as we will decrease the distance, they will
Attract.
immediately attract. It means as distance decreases, force of attraction increases. As distance increases, force of attraction decreases. So it is inversely proportional to the force. Force is inversely proportional to the square of distance between them, right? So combining these two statements, force is directly proportional to m1 m2 upon r square. Clear? So what must be our statement? Statement must be every particle of matter attracts every other particle. That is most important. That is every particle of matter attracts every other particle of matter with a force which is directly proportional to the product of their masses and inversely proportional to the square of
distance between them.
right? So if in case they ask to write it in your board examination, already board examination has been over, but in case those who are listening to me and they will give that board examination in the upcoming days or months, so they have to understand this statement and then they will write, right? Now mathematically we cannot utilize this statement directly. Why? Because it is proportionality. Mathematically it must be equality. It must be
Equality.
So for that we have to consider something called as proportionality constant, and for that we have considered
Capital G.
capital G. Many of the times student may interpret it wrong that this is acceleration due to gravity. It is not at all acceleration due to gravity. It is what? Proportionality constant, right? It is proportionality constant, and that is termed as universal gravitational constant. Universal gravitational constant. Now during CET, JEE or NEET examination, they usually ask dimensions of capital G. Dimensions of capital G. But if we are mugging the dimensions, in that case we may select a wrong dimension. So instead of mugging, what we should do? We should understand how to calculate the dimensions. Many of these students are still not getting how to calculate the dimension of any physical quantity. So we'll see how to calculate the dimension. But before moving that, for this particular model 1, we have few questions for you. Try to answer that questions. Before answering it quickly, please read the questions carefully and then answer. The question is, gravitational force is directly proportional to option A, product of masses, sum of masses, division of masses, and each of masses. So we will see the prerequisite. Gravitational force F is equal to G m1 m2 m2 upon r square. It means gravitational force is directly proportional to
Product of masses.
Product of masses.
Masses.
So answer must be
A.
option A. Now moving ahead, gravitational force is mathematically given as. So we will see what we have discussed earlier. So we have discussed this, that F is directly proportional to m1 m2, F is directly proportional to 1 upon r square. But for that we have chosen gravitation proportionality constant, that is universal gravitational constant. So the formula is F is equal to G m1 m2 upon r square. So the correct option must be
C.
C. Good. Now, in the Newton's law of gravitation, G called as. So it is very easy to answer, universal gravitational constant. But again here student make mistake. They usually select acceleration due to gravity. But what is acceleration due to gravity? Small g. So the correct answer is universal gravitational constant. And what is small g? Acceleration due to gravity. That we will cover up in the next module. So now it's time to start module 2 because we need to understand the dimensions of G. Dimensions of G. So we have started module number 2. So universal gravitational constant capital G. Earlier we have studied F is directly proportional to
G.
this is what? Newton's law of gravitation. Based on this, we have written this, that F is equal to capital G m1 m2 upon r square. Even though you are recalling or even though you are learning it or reading it, you must treat it as F is equal to capital G m1 m2 upon r square. So if we need to convert this formula in terms of capital G, then what will happen? The terms which are multiplied on left hand side, that became divided on right hand side, and the variables which are in division will come here as a multiplication. So here r square is in the division. When we will take it to the next side, that will be multiplied with F, and m1 m2 are multiplied with G. So when we take it on the other side, they will get divided. So finally formula is capital G is equal to capital F r square upon m1 and m2, right?
Yes.
So this is our formula. Now suppose we will consider in CET they may ask m1 m2 is 1, distance between them is unit or 1, then options 1 A, G is not equal to F, 2 G is equal to F, 3 G is greater than F, and 4 G is less than F. So even though they have asked you to put the values m1 m2 1 into 1 and the r is 1, so r square था यहाँ पर. So if I put 1 square into F and G, so what will happen? 1 का square 1 into 1. So obviously G is equal to F. So in examination they may give these options to you. And the correct answer must be G is equal to F. Now, universal gravitation constant is numerically equal to the force of attraction between two unit masses placed at unit distance apart. Is that unit distance apart? Remember this. So G is equal to F, that we have already derived. So SI unit of G is Newton meter square upon kg square. Why so? Many students generally ask, sir, how nm square or what is nm square? So n is for force and m is for distance. Meter is for distance and distance square. Therefore, meter square. And masses are measured in kg. So there are two masses, kg into kg became kg square. So the SI unit of capital G is what? Nm square, that is Newton meter square upon kg square. Now, in examination they usually ask CGS unit of G. So that is dyne centimeter square upon gram square. But again, instead of asking CGS unit, they generally give you a CGS unit and they generally ask you to find out the dimension of it. So you might get confused. Why? Because they have given G in terms of CGS unit, that is dyne centimeter square upon gm square, and they usually ask you to select the dimension. So how we can calculate the dimension, that we will see. Dimensions of G. So representing this G in terms of dimension, so we have separated F, we have separated R square, we will consider M1, M2 separately. Now dimension of force is M1 L1 T raised to minus 2. M1 L1 T raised to minus 2. Now you may ask question, sir, from where we derived this? So what is force? Force is equal to mass into acceleration. Now what is acceleration? Velocity upon
Time.
velocity upon
Time.
Now what is velocity? Displacement upon time. Displacement upon
Time.
and this time. So time became time square. So we have mass, distance and time square. So for mass, what we will consider? Capital, that is 1. For distance, we will consider capital L, that represents length. And for time, capital T. Then why it is minus 2? Because it is in denominator. When that power goes in numerator, that must be negative. That must be negative. So here we have derived a dimension for a fundamental, for a derived quantity, force. From the fundamental quantities, mass and distance and time. So here those who are not aware what is derived physical quantity and what is fundamental quantity, for them we have derived the physical quantity of F from the fundamental quantities of mass, distance and time. So these are all fundamental quantities which cannot be derived from anyone, which are uniquely dependent on themselves. Mass, distance and time. Mass is measured in
kg.
distance is measured in time is measured in. So including all these three fundamental quantities, we have derived force,
Yes.
right?
Yes.
And for that, the dimension of force is m1 l1
T minus
t minus 2. right?
Yes.
How to calculate dimensions, I think it is very much clear to you. Am I right?
Yes,
Yes,
sir.
sir.
Sure?
Yes,
Yes.
sir.
So, first dimension is for force. Now, second dimension is for r square. What is r? Distance.
Distance.
What is r?
Distance.
So, distance does not require mass.
Yes.
So, we have mentioned 0.
Zero.
Then distance does not require time.
Time.
So, we have mentioned it as 0. So, distance is only length. That's why we have mentioned L2. Clear?
Yes, sir.
For M1 and M2, these are already masses.
Yes.
It does not require any length, it does not require any time. So we have mentioned M1, M2, kg, so 2, so M2,
Two.
right?
Yes.
I think this step is very much clear to everyone. Am I
Yes,
right?
sir.
Yes, sir.
Moving ahead, if we will take this M2 on the upper side, that became M minus 2. Pay attention. If we will take this M2 on the upper side, that became M1 M minus 2. And here already M is M0. So M1 M minus 2. 1 minus 2
Minus one.
M minus 1. So minus 1 is right. Then considering L, so L1, L2, L0. So neglect this L0. 1 plus 2 is
Three.
so that is L3.
Yes.
Clear?
Yes.
Yes, sir.
Now looking at time,
Time.
we have only t raised to minus 2. Rest every t is 0. So we consider t raised to minus 2. So this is what is the dimensions of
Capital
G. How we have derived that we will quickly see. G is equal to F R square upon M1 and M2. Considering each quantity separately, the dimension for force is M1, L1 t raised to minus 2. For the dimension of R square is M0, L0, T0. Dimension of M1 and M2 is M2, L0, T0. Considering all the constraints in the numerator and denominator, we have derived M raised to minus 1, L3, T raised to minus 2. So you have to remember this as you have to answer this in CET, NEET or JEE. Now, what is the value of G? 6.67 into 10 raised to minus 11 Newton meter square upon kg square. Now the same value we can write it in CGS. 6.67 into 10 raised to minus 8 dyne centimeter square upon GM square. Right? Those who want to note down all this thing, they can pause the video anytime and they can note it down afterward or they can revise it. Now, based on this, we have few questions. Read the questions carefully and then we will answer. So, I'll read it for you. First question. Universal gravitation constant is numerically equal to. We have 4 options. So, we will just think about our previous knowledge and then we will answer. What was our previous knowledge? Universal gravitational constant is numerically equal to the force of attraction between two unit masses placed at unit distance apart. Unit distance apart. So option must be A. So dimension of gravitation constant is, just now we have derived that too. We'll just recall it again. So this is what the step which we have done earlier. So finally the dimension is m raised to minus 1 L3 and
T minus 2.
t minus 2. So option
C.
C is the correct option. The value of gravitation constant in SI unit is, so we will see the previous prerequisite knowledge. Value of G 6.67 into 10 raised to minus 11 Newton meter square per kg square. So option B is the correct. In case if they have asked you in the CGS, then the answer must be 6.67 into 10 raised to minus 8. Okay. So now it's time to go for model number 3. Today we are going to complete gravitation, right? So nearly 30 models are there. So we will conduct it in different parts, 1, 2, 3, then 3 models we will consider in various parts. So characteristics of gravitational law. So we know F is equal to capital G m1 m2 upon r square. The gravitational force is independent of intervening medium, whatsoever may be the medium in which objects are interacting. It is independent of intervening medium. So gravitational force is conservative force. It can be conserved from one object to another object. Is that clear?
Yes, sir.
The force exerted by the first particle, pay attention, the force exerted by the first particle on the second is exactly equal and opposite to the force exerted by the second particle on the first. We might have heard about 3 laws of Newton's. So third law is every action has equal and opposite reaction. Considering that the force exerted by the first particle on the second is exactly equal to the
Opposite
force exerted by second on the first. And the gravitational force between two particles act along the line joining the two particles and they form an action reaction pair. So we will quickly revise the characteristics of gravitational law. First, the gravitational force is independent of intervening medium. The gravitational force is independent of intervening medium. Second, the gravitational force is conservative force. It means that can be conserved from one object to another, which comes in contact with all the objects. The force exerted by the first particle on the second is exactly equal and opposite to the force exerted by the second particle on the first. And the gravitational force between two particles act along the line joining the two particles and they form an action and reaction pair. Now considering this, we have few questions for you. First, the gravitational force doesn't depend on. So we have 4 options. We will see the prerequisite knowledge and then we can answer for that. So we have enlisted these many characteristics. Based on that, we can answer that it is very much independent on intervening medium. They have just changed the words that it does not depend, and while studying we have discussed independent. So one and the same. Okay. So I hope we have covered as much as possible in the part 1.
Yes.
In the part 2 we will start model number 4, model number 5 and model number 6. Those who want to revise or those who want to note down anything from that to extract any MCQ, you can go and check the videos and pause it and note it down. Thank you so much.